Newton's Second Law by Hannah, Sarah, John, and me.
In the picture on the top of the page, you see one cart by itself, and then you see multiple carts together. Newton's second law describes that if you push the carts with the same amount of force, that the acceleration of the cart by itself will go faster. And we'll tell you how that works in the next few slides.
We are going to show you an example. As you can see, the bigger gymnast, when she's going, it's harder for her to do it and she's not accelerating as fast. But when you see in the next video, the littler one accelerates quite a bit faster. She's getting a lot faster, as you can see, because she is smaller and has less mass. So she'll accelerate faster, like in the double flip.
Newton's second law states that force is equal to the change in momentum per change in time. For a constant mass, force equals mass times acceleration. Let's give you an example. Right over here, you see a big bowling ball and a small, tiny golf ball. If you take a golf club and whack the bowling ball with it with, let's say, 10 newtons, I'm going to tell you what, it's not going to go very far. But if you take the golf ball and hit it with that same amount of force, it'll go much further. Because in Newton's law, it says, and also down in this picture, smaller mass, large acceleration with the same force, and large mass with small acceleration.
Acceleration and weight. Acceleration measures a change of velocity, and weight is a measure of force of gravity pulling on an object given a mass. So as below, there is a car, it's 30 newtons, and there's a soccer ball of 30 newtons also.
So as she said, the soccer ball has a smaller mass, so it'll go much faster than the car if you push on it with 30 newtons.
If you guys didn't know what velocity is change in speed and direction.
We're going to show you another example of the second law. In the video, I am hitting two balls. One of them is a golf ball, and the other one is a small bouncy ball. The video is in slow motion, so it'll be easier to see. Hit the balls with about the same amount of force each time. So right now, I'm going to hit the golf ball. And when I hit the golf ball, I hit it with the same force as the bouncy ball. You see, it doesn't go very fast, but it's still pretty good speed. Now, when I hit the bouncy ball, it goes faster than the other ball because it has a smaller mass, and that's Newton's second law of motion.
How to calculate this equation. We are going to give you some problems, and we are going to solve them. Okay, we are going to remember that force equals mass times acceleration. Suppose you're on a football team and you are given two choices for someone to tackle you. Person A has a mass of 130 kilograms and the acceleration of 20 meters per second. Person 2 has a mass of 140 kilograms and has 10 meters per second of their speed. Which one would you like to be tackled by? So how you're going to solve this is you're going to find the force, so you're going to take the mass right here, times it by the acceleration to find the force. So what we're going to do is 130 times 20 is 2,600 in other words. And then person B, 140 times 10 will be 1,400. If I were you, I would get tackled by person B, because he's a lot lighter. We can also teach you how to do it with the gravity. You can, let's see, the speed of gravity is 9.8 meters per second. If Sarah and John are jumping off a cliff into Lake Pactola, what is their force? Sarah's mass is 56 kilograms and John is 50. Who has a greater acceleration force? Okay, so instead of multiplying it by that, we're going to times it by 9.8. So 50, which is his, times 9.8, which will equal 490 meters per second, which is pretty big. And then 56 times 9.8, which will get you 548.8. So who has the greater acceleration force? It will be Sarah. Thanks to the second law of motion.
Direct relationships are the greater force applied to an object that are faster than its accelerates. And inverse relationships are as one increases, the other decreases. If one decreases, the other increases.
For the inverse ones, if one goes up, the other one's going to go down. So, and then the direct relationship, so the greater the force is applied, so the greater is more pressure on the object, the faster it's going to go.
We have an example below. If the same person hits two different balls, one of them being a softball and the other one being a baseball, if you hit the baseball, it'll go further in a straighter path. But if you hit the softball at the same speed, it won't go as far in a less straight of a path as the baseball. Well, that's Newton's second law of motion. Thank you.